So this is called complex plane. Complex plane. In fact, the addition is very much similar to the addition of vectors. For example, if you consider this is x-axis and this is y-axis, and if we consider this vector, let us say this is a vector and this is another vector, say this one, say this is z1 and this is z2. If we are required to add these two vectors, you know, we use always parallelogram law. So in case of the vectors, we must draw a parallel vector to this vector. Say this is a parallel vector to this vector, then there must be a resultant vector over here, okay, and this is z1, so it is z1 plus z2. This vector here up to here is z1 plus z2. The addition is very much similar to the addition of the vectors, okay, using the parallelogram law. Then complex conjugate. Complex conjugate, it is just reflection of, for example, if we have, say this is z, okay, if this is z, complex number, then its reflection in x-axis is, this is the reflection in x-axis of this complex number, and this reflection is denoted by z conjugate, its conjugate. So if this is x and y, then this point is x and minus y. This point is x and minus y. X is the same, whereas y is reflection. Okay. So if z is equal to x plus iota y, then its conjugate is x minus iota y. This is the conjugate. So what we are doing over here, to find the conjugate, just change the sign of the complex part over here, imaginary part over here. If there is negative, for example, if we have 1 plus 2 iota, then its conjugate is 1 minus 2 iota. And if we have 1 minus iota, then its conjugate is 1 plus iota. If the number is here, then its reflection is here. If the number is here, then its reflection is here. So the double reflection will give you the same result. For example, this z conjugate is in fact the same number. The double reflection will give you the same number.
The first case you add two vectors z1. You started z1 from the arrow of z2. There is the vector to start from the origin. So if you start z1 from the origin, it's the same as z1 plus z2.
In fact, what we are doing over here, we are translating the vector, this vector. In fact, this vector is translated, let us say again. For example, we have this vector, okay. First we have translated this to this point. So in translation, what we are doing? We are increasing the real part only. First we increase the real part, certain units over here, say x units over here, okay, and then it is translated again in y-axis. So then we have increased the y as well. So in fact this vector, if this is, say this is 1 and 2, this will not be 1 and 2. This will be something else, which is obtained after increasing x and y. However, in length both will be the same. ठीक है जी?